Next topic is diagonalization of a matrix. So let A be a symmetric matrix. Form a matrix N whose columns are normalized eigenvector of A. Since N is orthogonal. Orthogonal means we know that the condition is N transpose is nothing but N inverse. Okay. So diagonalization, how we can write it means N transpose A is the given matrix. N is the normalized matrix. It's called as a orthogonal reduction or orthogonal transformation. So for to do orthogonal transformation using a diagonalization, this is our formula. So how we have to do it? For that correspondingly, the first problem, diagonalize the matrix. Okay, so A matrix has been given by means of the orthogonal transformation. Orthogonal transformation only we are doing. First thing, the A matrix diagonalization when we do means it should be a symmetric matrix. Then only we can do. Okay, other cases and all we cannot apply a diagonalization matrix. Okay, it should be a symmetric matrix. Check your question, it is a symmetric. You need not check it. Okay, so if it is given means diagonalization itself, it will be a symmetric matrix only. The question will be given, then we can do it. So first step, first I will be writing the characteristic equation. So the characteristic equation, A minus lambda I equal to 0. So 3 minus lambda 1, 1, 1, 3 minus lambda minus 1, 1, minus 1, 3 minus lambda, the determinant value equal to 0. So we will be writing the shortcut. So shortcut when you write it, so it is nothing but lambda cube minus s1 into lambda squared plus s2 into lambda minus s3 equal to 0. Find out here s1 and s2. Okay. Find out here s1 and s2. S1 is sum of the diagonal elements. It's nothing but 3 plus 3 plus 3. So it is nothing but 9. Okay. S2 you calculate it. S2 is nothing but 3. The sum of the diagonal elements. First diagonal element, leave your row on column. Remaining element you write it in a determinant format. 3 minus 1 minus 1 3 plus the next diagonal element is 3. Corresponding row on column you omit. Remaining you have to write it in a determinant format. 3 1 1 3. Same with the last diagonal element is this 3. So leave your row on column. Corresponding element it should be written in the determinant format. So now I calculate. It's a 9 9 minus 1 8 9 9 minus 1 8 9 9 minus 1 8. It's nothing but 24. S3 you can calculate in a calculator. The determinant of A is nothing but 16 when I calculate. Okay. So everything we'll substitute here. Okay. So all the value when I substitute, I'll be getting here lambda cube minus 9 lambda squared plus 24 lambda minus 16 equal to 0. Now we need to calculate the lambda. Okay, eigenvalue, eigenvector, we have to do it. Okay, so now eigenvalue by a synthetic division you can do it, or using the calculator, the cubic polynomial, you can calculate in a calculator. I will do by synthetic division. 1 minus 9, 24 minus 16. Okay, so when I do it by synthetic division, here 0, we are making it a 0 here. So I will try it for 1. Okay, so 1, if I try it, 1 1 minus 8 into 1 minus 8, so 16 into 1, so it becomes 0. So one of my eigenvalue is nothing but 1. Other two values I have to calculate using the equation. Okay, so now this equation you consider, it is lambda squared minus 8 lambda plus 16 is the equation equal to 0. Now write it in a product of two terms, you check it, lambda, so minus 4 lambda minus 4 equal to 0. Check it. Lambda square minus 8 lambda 16. Yes, is correct. So the other two eigenvalues are 4 and 4. So totally the eigenvalues, three eigenvalues are 1, 4, 4. The three eigenvalues are 1, 4, 4. Which type it is? Check it. Repeated eigenvalue. The matrix is symmetric. So it is under type 3. Okay, first you decide which type it is. Then only that procedure you have to do it. What is your type 3 procedure? We have to first find the two eigenvalues. Okay, so two eigenvalues. First we need to find it. So the eigenvector we have to find it. The eigenvector, first I will write it the format. It's a minus lambda I into x. X is nothing but column vector equal to 0. Now when I write it in this format, I'll be getting 3 minus lambda 1 1. So 1 3 minus lambda into minus 1. Here 1 minus 1 3 minus lambda into x1 x2 x3 equal to 0 0 0. Okay, completed. Now for non-repeated first, lambda equal to non-repeated means lambda equal to 1. Okay, non-repeated is 1. Okay, for 1 we are going to first find the eigenvector. So when I calculate it, lambda equal to 1, I will calculate it. So substitute 1 in this. So it's nothing but 2 1 1 1 2 minus 1 1 minus 1. Here it is 2. Okay, so three set of equation. Okay, take only two set of equation. By using a cross multiplication rule, we are going to find out the eigenvector. So write the equation first. So all the three you can write it. So take only two equation. X1 2x1 plus x3 equal to 0, first equation. X1 plus 2x2 minus x3 equal to 0. Third equation, x1 minus x2 plus 2x3 equal to 0. So only I am going to take first two equation. Always why you are taking the first two equation, not like that. Any two equation. Okay? You will be getting the same answer only. It will be in multiples only, the difference will be. Okay? So now I have taken, now you cross check. If it is x1 means, okay, if it is x1 means, okay, if it is a x1 means, omit x1, remaining you have to write it in a matrix format, 1 1 2 minus 1, completed. If it is x2, if it is x2 means omit x2, remaining will be in a matrix format, 2 1 1 minus 1. X3 means omit your x3, remaining you have to write it in a matrix format, 2 1 1 2. Okay, this minus symbol don't forget. Okay, when I simplify it, minus 1 minus 2 minus 3. Here minus 2 minus 1, so minus 3. Here also 4 4 4 minus 1 3. So now when I write my first vector x1 is nothing but commonly divide by 3. Okay, commonly all three are divisible with 3. So my vector will be minus 1, minus symbol and minus symbol plus 1, third only 1. So this is my first vector. My first vector I have calculated. Okay, for a non-repeated. Now we have to calculate for a repeated value when lambda equal to 4. So now lambda equal to 4, I am going to calculate the second vector. Okay, second vector when I calculate it, the same way you write the lambda equal to 4, you substitute in the equation, you will be getting the equation to be minus 1, 1, 1. So 1 minus 1 minus 1. So 1 minus 1 minus 1 into x1, x2, x3 equal to 0, 0, 0. Now you check the equation. All the three equations are same. These both are in only in minus symbol it change. When I divide by minus 1, it is the same equation as equation 1. This you divide by minus 1, same equation as equation 1. So only one set of equation. X1 minus x2 minus x3 equal to 0. I'm writing this format. Okay, x1 minus x2 minus x3 equal to 0. Now what you have to do? Put x1 equal to 0. When I put, I will get in this equation x2 equal to minus x3, which is nothing but equal to k. K equal to 1 you take. K equal to 1 when I take, x2 equal to 1, x3 equal to minus 1. So I'm getting the solution to be the solution. Now when I write it in a matrix format, I have to write the x2 vector. Okay, so second vector. So x2 vector is nothing but x1 taken 0, x2 as 1, x3 as minus 1. You may get the solution to be opposite also. 0, minus 1, 1. Okay, this is your another vector. Any one, it's enough. Okay, x2 vector calculated. Already x1 vector, x2 vector now calculated. We need to find the third vector. But it is a, which type it is a? It is a symmetric. It is a third type. So third type means what you have to do? So already I have mentioned third type means what I have to do means first we have to symmetric, because in the question it's given to be A is symmetric matrix. A is symmetric matrix means orthogonal condition satisfied. The eigenvector satisfies your orthogonal condition. Okay. The eigenvector satisfies orthogonal condition. Okay. So orthogonal means my new vector x3, I did not calculate it. I am taking to be A, B, C. Okay. If I take x1, A, B, C, because I am going to write it in a column only, but I am going to find out some answer. I don't know that answer. I am taking A, B, C general. Okay. So if I have it like that, then x1 transpose, because orthogonal condition satisfied, x1 transpose is my calculated eigenvector. Okay, that into my new vector, I will be getting orthogonal condition, it is 0. Correct? Same way, x2 vector I have already calculated. x2 vector transpose in the new vector I am going to calculate it. That I get, it's a orthogonal condition satisfied. Okay. So this is our orthogonal condition. So now this I am going to write it. Okay. So how can I write it? So write. So when I write it, so when I am able to write it, x1 transpose into x3 equal to 0. So how can I write it? x1 transpose is nothing but, okay, I will write it here. x2 transpose means in column wise is there, I can write it in a row wise. It is 0, 1, minus 1. Correct? Huh? Same way, I will write it. x1 transpose also I will write it. Same way we will write it. Here, x1 transpose, how can I write it? So it is minus 1, 1, 1. Okay, this both only I am going to use it here. Okay, when I use it, so it's nothing but minus 1, 1, 1 into x3 is A, B, C. It is equal to 0 means how will you write this matrix? So it's minus A plus B plus C equal to 0. Correct? Same way, x2 transpose into x3 equal to 0. So now when I am able to write 0, 1, minus 1 into A, B, C, okay, equal to 0. How can I write it in equation? 0A plus B minus C equal to 0. Now I have two set of equations solved by cross multiplication rule. So by cross multiplication rule, so when I solve it, I will get A minus B C. Okay, A when I do a calculation, A when I do a calculation, hide cross multiplication rule, what it is here, cross multiplication. A hide it, remaining elements you write it in a determinant format 1 1 1 minus 1. Correct? B you hide it, same way you write it in a determinant format 1 1 0 minus 1. Okay, C you hide it, remaining determinant format minus 1 1 0 1. So completed. Calculate the answer for this correspondingly. So minus 1 minus 1. So minus 2. Correct? Minus. So now 1. Okay. In this minus 1. Okay. So our new vector will be x3 vector. When I write it, it's nothing but minus 2 minus symbol. So minus 1. Here minus symbol. So minus. Let me see, check. Correct? Yes. Correct. So this minus minus. Okay. So minus 1. Okay. Here you'll be getting minus 1 is our new vector. So after finding, okay, till eigenvalue and eigenvector we have calculated, what we have to do means we have to write the modal matrix. What do you mean by modal matrix? Means modal matrix, I will take the notation for that M. Okay, it's our wish only. I am taking M. So all the eigenvector, write it in a column wise. Okay, all the eigenvector, write it in a column wise. For example, first eigenvector minus 1, 1, 1. Okay, my second eigenvector 1, 1, 0. Correct? So my third eigenvector, I will check second eigenvector. What is our second eigenvector? Sorry, 0, 1, minus 1. I will change 0, 1. My second vector is 0, 1, minus 1. Okay. My second vector is 0, 1, minus 1. My third vector is minus 2, minus 1, minus 1. Okay. This is our third vector. I am not doing anything. The same order I am writing in a column wise. That is called as a modal matrix. Okay. After writing a modal matrix, you have to write the normalized modal matrix. Normalized this modal matrix that is denoted by the symbol n. Okay, so how we have to write it means this minus 1 as it is minus 1 divided by square root of in the column wise only. Okay, in the column wise only this minus 1 squared. Okay, 1 squared minus 1 the whole squared plus this 1 squared plus 1 squared. Okay, same way here it is the same element. Whatever you get this answer, that element. So 1 root 3. Here whatever the same answer 1 by root 3. Okay, so completed. When you do it for here 0 will be 0 only. Same way 1 divided by square root of 0 squared 1 squared minus 1 the whole square. So root 2. Same way minus 1 divided by root 2. Okay, same way here when you do it minus 2 divided by 2 minus 2 the whole squared is 4. 4 plus 5 6 root 6. Okay. Same way here it is for minus 1 by root 6 or minus 1 by root 6. So completed. So this is called as a normalized modal matrix. Okay. After finding a normalized modal matrix, what is our diagonalization? D. D is nothing but n transpose into A into n, our diagonalization. Okay. So n transpose, first for that we need to write n transpose is nothing but n transpose, already you know, it is nothing but row into column, column into row. So here it is minus 1 by root 3, minus 1 by root 3. The second element is 0, will be coming here, minus 2 by root 6. Okay, I'm interchanging and writing this row fully, writing in a column base. Next row fully, writing in a column base. So 1 by root 3, 1 by root 2. So minus 1 by root 6. Same way 1 by root 3. So minus 1 by root 2, minus 1 by root 6. So completed. So n transpose. Okay, this n transpose into the given matrix A into n. You multiply it, you get your diagonalization. For that, how you have to multiply it means, first you have to multiply the first two elements only. N transpose into A, you have to multiply it. Okay, not from the reverse order. First you have to multiply this both the elements, then that answer into n. Okay, answer into n, you have to multiply it, then only you will be getting your D. Okay, first step n transpose, this and all you can do it in a calculator itself, the multiplication. 1 by root 3, 1 by root 3, 1 by root 3, 0, 1 by root 2, or minus 1 by root 2, minus 2 by root 6. Okay, so minus 1 by root 6 into minus 1 by root 6 into A matrix. A matrix, already we know that it is nothing but 3, 1, 1, here 1, 3, minus 1, 1, minus 1, 3 into again n. N I will have it as it is. This both you multiply it, you get one answer. That you write the calculation answer, you write, then into n you multiply it. So overall everything you can do it in a calculator, but you have to multiply n transpose and into A, that answer you have to show it here. Okay, so that answer into n matrix. Okay, multiply it, you get one answer, that will be diagonalization, that you can guess. Diagonalization you can guess the answer. It is nothing but the eigenvalues, diagonal elements in the, what is our eigenvalue? You remember the eigenvalues we got in the starting 1, 4, 4. So this eigenvalue in the diagonal elements. Okay, remaining elements, it may be a lower triangular or upper triangular, it is 0. It is called as the diagonalization. Okay, this is our diagonalization. See here we got, this is our diagonal elements 1, 4, 4. Any order, it may be 4, 4, 1, or some cases 1, 4, 4. Okay, or 4, 1, 4. Any order you may get, but it is not wrong. Okay, the same way eigenvector also. So you take some other thing means it will change. Only the corresponding elements will change, but same answer only you have to get it. The diagonalization you will be getting the eigenvalues in the diagonal elements. Okay, that is our diagonalization. If it is not coming means somewhere you have done a mistake in the eigenvector. You have to correspondingly check the eigenvector. So this is called as a diagonalization. Thank you.